In this problem, our assignment is to find VA, and we will be utilizing the problem-solving strategies entitled single-loop circuits and circuits with dependent sources. And if we look at this circuit is a single-loop circuit, and it also has a dependent source. So if we look at our problem-solving strategies, for instance, for single-loop circuits, the first step is to define a current. Okay, and I'm going to define the current I1 in that direction. And then the next step is to assign a voltage across each resistor in terms of that assigned current. So for instance, for this resistor, the voltage is 5K I1 with that polarity, and the polarity comes going back to Ohm's law and looking at the convention we established for voltage and current there. For this resistor, we have 10K I1. And down on the bottom with this resistor, we have 5K I1. Okay, so now we've completed the first two steps. Now we're going to apply KVL, and if we look at this problem-solving strategy for circuits with dependent sources, we're going to treat that dependent source like an independent source in writing the KVL equation for the circuit. So let's start here, and let's go around the circuit counterclockwise. So if we start, we'll have here, we've got a voltage drop. We hit the plus sign, so we'll have 5K I1 minus 2Vx. Okay, here we encounter a voltage rise with the minus sign. Then we'll have here, we'll have plus 10K times I1 as a voltage drop across this resistor. And as we come around, we hit the plus sign on that 12-volt source, so we have plus 12. Then as we come around for this resistor, we'll have 5K I1. And then as we come around to this source, we're going to hit the negative sign, so we're having a voltage rise, so we're going to write that as minus 36 equal to 0. Okay, now, as we collect terms here, we can reduce this equation to 20K I1 minus 2Vx equal to 24. Okay, now we're going to express the controlling variable Vx in terms of our unknown current I1. So if we look at this resistor, we look at the way Vx is defined, and we look at the polarity here as determined by the defined current. So Vx is equal to minus 5K I1. So now substituting this in, so we have 20K I1 minus 2 times minus 5K I1 is equal to 24. So this gives us 30K I1 equal to 24. So then I1 is 24 over 30K, which is 0.8 milliamps. And since it came out positive, then the current's actually flowing in the direction in which we assumed originally. Now this doesn't allow us to solve for VA yet. If we look at our circuit diagram, and if we do KVL around this loop, so we're going to go from here all the way around to here and then back through to here. If we do that for VA, VA turns out to be 2Vx minus 5K I1. Okay, So that's from Kirchhoff's voltage law. Now if we look at Vx, this is minus 5K times 0.8 milliamps, which says that Vx is minus 4 volts. So now we have 2 times minus 4 minus 5K times 0.8 milliamps. And that turns out to be minus 12 volts.